Hello. Today we're going to be learning about multi-step equations, which is skill 4. Let's start with some guidelines to solving multi-step equations. You want to start by simplifying each side separately. Make sure you're writing this down on your note-taking sheet. Simplify each side separately. Then you want to use your distributive property to remove parentheses. And then make sure that you combine like terms on each side. Now we want to look at variables and constants on opposite sides. So you want to combine variables and constants on opposite sides using addition or subtraction. Once you have all your variables together and all your constants together, you can then isolate the variable using using division or multiplication. Let's try one and go through these steps together. So we've got example 1 here. We've got -2 times x plus 2 equals 16 minus 3x. So our directions are to simplify each side separately. So we've got two sides here that we're going to separate, and we're going to look at each side separately. If we look at the left, we see a set of parentheses there, so I'm going to use distributive property to remove those parentheses. And then I'm going to bring down the other side. There's no more like terms here, and no more like terms here, and no more parentheses. So I'm ready for step 2, which is to combine the variables and the constants on opposite sides. We're going to use inverse operations to do that. So instead of subtracting 3x, we're going to add 3x to each side. The -3 and the +3 become 0. -2 plus 3x is 1x, and I'm going to bring down the -4 and the 16. Now I want to get the constants together, so I'm going to add 4 on each side. So x equals 20. Now we want to check that in our equation and see what happens. So I'm going to replace the variable with 20. And I'm going to simplify each side separately. So on the left-hand side, order of operation tells me to do parentheses first. There's no reason to do distributive property there. On the right-hand side, order of operations tells me to multiply first. So 3 times 20 is -60. -2 times 22 becomes -44, and 16 minus 60 also becomes -44, so that I know that my answer x equals 20 is correct because the two sides balance. Let's try another one. Let's look at example 2. We've got two sides and we have parentheses. It's the 3 that's directly in front of the parentheses, so the 5x is just going to come down. Then that becomes 3x plus 12 because distributive property is just multiplication. I've removed parentheses, but now I have some like terms here. I have 5x and 3x, which becomes 8x. I have no more like terms on the left. 8x and 12 are not like terms, and there's only one constant on the right. So I'm ready to move on to looking at variables and constants on opposite sides. There's only one term that has an x in it, so I can just leave him alone, but I want to move the 12 over with the 28 by doing the opposite. I'm going to subtract instead of add. So I get 8x equals 16. Now I'm ready for step 3, isolate the variable using either division or multiplication. In this case, I'm going to divide because 8 times x, the opposite of that would be dividing both sides times 8. So x becomes 2. To check, I'm going to replace each x with 2 and see if my equation balances. So when I do all this work, I should find out that the left-hand side becomes 28. Parentheses first, so I'm going to do 2 plus 4, which is 6. 5 times 2 becomes 10, 3 times 6 becomes 18, and 10 plus 18 does indeed equal 28, so that I know my answer x equals 2 is correct. Let's look at another one. For this one, we don't have any parentheses and we don't have any like terms on each side. We do have like terms on opposite sides. I'm going to move my x's to the left using subtraction and bring everything else down. And I'm going to move my constants to the right using subtraction because the 15 is positive. So I get negative 2x equals 30. I'm going to divide both sides by negative 2. So x should be negative 15. But let's check our answer and see if we're correct. We're going to replace x with negative 15. 6 times negative 15 becomes negative 90. 8 times negative 15 becomes negative 120. 15 minus 90 is negative 75. 45 minus 120 is also negative 75. So I know that my equation does indeed balance and x has to be negative 15. All the equations we've worked on so far have had one solution. We can also see equations that have either no solution or infinite solutions. In no solutions, the equation will never balance, we'll never find an answer that works. With infinite solutions, any answer would work. So let's look at example 4. There's no parentheses, there's no like terms on each side, so I'm going to move the x's to be on the same side. I'm going to add 8x to each side to do the opposite. I bring down the 7. The negative 8x and the positive 8x cancel out. A common mistake people make there is bringing down an x, but that would mean that negative 8 and positive 8 add together to make 1. They don't. They make 0, so the x's disappear completely. That happens on the right-hand side as well. Negative 8x and positive 8x add to be 0, so I'm just left with negative 17. There are no x's left. There are no variables left to solve for, and 7 does not equal negative 17. What we say in this case is there is no solution. A shortcut way to write that is the circle with a line through it. I think of that as if it's not even 0. There is no solution that will work there. We can't check something like that because it doesn't matter what number you use, this equation will never balance. Let's suppose we say x equals 1. We're going to replace x with 1. That becomes 7 minus 8. Excuse me, that should have just been a minus. And that becomes negative 8 minus 17. 7 minus 8 is negative 1. Negative 8 minus 17 is negative 25. Those do not check. There is no answer that will work there. It doesn't matter what we try. This equation will never balance. So there's no reason to check that one. Let's look at another one. For example 5, we've got 2 times 3x and 2 times negative 5. You should notice something right away about the two sides. They are exactly equal. If I go a step farther and try to get the x's to the same side, 6x take away 6x is 0, so I'm left with negative 10. 6x take away 6x is also 0, so I'm left with negative 10. Negative 10 will always equal negative 10. This equation will always balance. What we say for this is that it has infinite solutions, or a shortcut way to write this is what I call the laying down 8. To check that, we can make x equal to any number. Let's say we make x equals 1 this time. Let's go back to our original equation and replace all of the x's with 1. We do inside the parentheses first. 6 times 1 is 6. 3 times 1 is 3. 3 minus 5 is negative 2. And so negative 4 equals negative 4. This equation will always balance. It will always check. We could put any solution we wanted to in there. Let's take a look at a couple of Delta Math examples. Let's say you see a problem like this. You want to first make sure that you have your sheet of paper out and that you are showing your work. So when you're doing your Delta Math, you are solving the problem on your own paper first. So I'm going to distribute. I get 5x plus 10 equals 5x plus 10. Get my x's together on the same side. The x's will cancel out because 5x take away 5x is 0, and 10 will always equal 10. So in your drop-down menu there, you should choose infinite solutions. Once you choose infinite solutions, it's going to give you some items to substitute in. It says a value of x that makes the equation true is blank. You can choose any number there because remember, this answer has infinite solutions. So let's suppose we make x equal to 0. We're going to replace. Remember, we're writing this on our own paper so that we can get full credit for our assignments. This becomes 5 times 2. This becomes 5 plus 10. Ooh. That becomes 0 plus 10, not 5 plus 10. Sorry about that. And it does indeed balance. You end up at the end with 10 equals 10. Remember, there's infinite solutions here, so we can try another number. Let's try 1. So this becomes 1 plus 2. We have 5 times 1 plus 10. This turns into 5 times 3. This turns into 5 plus 10. 5 times 3 is 15, and 5 plus 10 is also 15. So this equation turns into 15 equals 15. Let's look at one that would have one solution. Again, you're showing your work on your own paper. So we're subtracting 10 from each side. We get x equals -5. You would choose one solution for this. The x's did not disappear. X has one solution, and that's equal to -5. So then when you check it, it says a value of x that makes the equation true. There's only one option here. You have to put the -5 in. So if you put the -5 in, -5 plus 10 equals 5. So the equation turns into 5 equals 5. Because there's only one solution, any other number will make this equation false. So you can choose anything there. I typically choose something easy to work with, like 1 or 0. And if I replace x with 0, 0 plus 10 is 10. 10 does not equal 5. That is not true. And so that's why 0 is not a solution there. All right, make sure that you're working on your Delta Math assignment and that you have finished up all of these notes. Have a great day.